So I'm Alexandre Ouzia, and I'm a research scientist at the Global R&D department of Heidelberg Materials. I'm in charge of machine learning application at the company and at the R&D department. Within the project, so I'm providing data to other stakeholders who would then analyze and build algorithm. There are, I would say, two answers. First, there is the impact potential. So cement, this grey powder that you mix with water and aggregates to make concrete, is actually one of the most produced materials in the world after clean water. As a consequence, it emits 5 to 8% of the global CO2 emissions. So if you can improve this by just a few percent, you would have actually a global impact on the CO2 reduction. So this is, let's say, the applied interest, but also as a scientist, cement is quite a pretty broad playground. You have a lot of open questions and questions which are connecting with other neighboring sciences. So typically the performance of cement is about strength, about rheology, about chemistry. So as you solve particular instance of problem in the context of cement, you are actually solving class of problem which apply to many other materials, and I think this is quite fascinating to discover the laws which are behind the curtain, and these laws are very transversal. One of the main driving force of the industry is how to reduce CO2. And the other challenge is digitalization. So we want to automate all of our processes, but this is absolutely not easy. So we speak a lot of AI and big data these days, but to implement that in the industry or even in academia is quite challenging. So why? Because in the first place, you need high quality data. The bottleneck is not to have the latest algorithm, the latest AI fancy technique, is to have in the first place a good data infrastructure which gives you high quality data on which you can actually retrieve some information. But to have that, you also need the right people. And this means you need people who are both trained in the domain, so you need domain experts, like in our case, cement scientists, but also people who are data scientists at the same time. Because to be able to be critical about the many ways, all the sensors that you put, how they can fail, or the biases that you can have, you need to have some domain expertise. And then to know which algorithm can be used and what they need as input, you need to be a data scientist. So this is, I would say, another challenge. And finally, there is a leadership and management challenge. People have their routine, and to implement the change, you need to change the habits of everybody from the operator up to the top managers. So the MatCHMaker project will help us on building better predictive models, so whether machine learning or physics-based model. And hopefully also it will help us on the data infrastructure part with the so-called ontology engineering. So this is a very new area of research and much remains to be done. But if this works, this could probably be a game changer. We could have, I would say, quite a good start with especially TU, so the Technical University of Vienna, and our collaborator also in Norway at SINTEF. We already exchanged some data and some image of electron microscope. Then will be available for analysis by our partner at the CEA in Paris and also IMAN in Spain. So we produce data about the compressive strength of new cement, so cement which emit less CO2 emission, and their role will be at TU Vienna to build the physics-based models, so from which they can basically predict these properties, and at the CEA in Paris they will build the machine learning models. At SINTEF in Norway, they will analyze the image, the electron image of these new cements, and this input image will be input data for the model at Vienna.